Sometimes we want to create high-resolution videos locally, but there's one big problem. High-resolution video generation requires a lot of computing power. The higher the resolution, the more RAM and processing power we usually need, and if you don't have a high-end GPU, generating high-resolution video locally can be very challenging. So, does that mean you can't create high-resolution video on a more modest GPU? Not necessarily. Today we're going to try a different approach with MiniMax H3. Instead of generating the entire video directly at high resolution, we'll start with a lower resolution video, upscale the latent directly, and then refine it at the higher resolution. This allows us to create a high resolution result while potentially reducing the computational cost of the initial generation. So in this video, I'll show you how this workflow works in ComfyUI, how to run the MiniMax H3 Latent Upscaler workflow in ComfyUI, and most importantly, whether we can really get a high-resolution result without relying on a high-end GPU. Let's get started. The MiniMax H3 Latent Upscaler is a custom ComfyUI node created by LBH123AI. You can find the project on GitHub. The idea behind this workflow is quite simple. First, we generate the video at a lower resolution, which means fewer latent tokens and faster generation. Then, we upscale the latent directly using the learned MiniMax H3 Latent Upscaler. Finally, we resample and refine the upscaled latent at the target resolution to recover and improve the details. Before we talk about the two-stage sampling process, let's first look at the basic parts of the workflow: the model, user input, and conditioning. The core of this workflow is the MiniMax H3 reference model, which is a multimodal model. It also uses turbo LoRA, which helps reduce the number of sampling steps and speed up the generation process. It also adds Comfy Kitchen Attention, an optimized attention backend built into recent versions of ComfyUI to help speed up the process. The user input tells the model what kind of video we want to create. This can include text, audio, images, or video, depending on what you want to create. The conditioning processes this information and provides guidance to the model. It helps the model understand the input and guides it during the video generation process. Now let's look at the two-stage sampling process used to create and improve the MiniMax H3 video. In the first sampling process, the model and sampler work together to create a lower resolution version of the video. A preview allows you to see the initial result before it moves on to the next step. Next, the video is separated from the audio. The video goes through the MiniMax H3 3D Latent Upscaler, which increases its resolution while it is still being processed. After that, the video and audio are combined again. The upscaled video then goes through the second sampling process. This second step helps refine the video and add more detail. Finally, the processed video goes through VAE decode, which converts the video data into actual video frames and creates the final visible video. Now let's try a simple example and see how this workflow works in practice. I'll start by uploading one reference image. This image provides the visual information for the video. Next, I'll enter a simple prompt describing what I want the video to look like. We also changed a few settings. We set the video length to 8 seconds and the target megapixels to 2, which is the highest setting. Once I click Run to start the process, the workflow begins generating the video. When it reaches the first sampling process, you can see the progress and preview the initial result. If you're happy with it, you can let the workflow continue. If you're not happy with the result, you can cancel the process, adjust your prompt or input, and run it again. This can save you time instead of waiting for the entire process to finish. Once the upscaling and video generation are complete, you can find the final result in the Save Video node. Now let's take a look at the final result. Let's try another example and see the difference. So that's it. We generate the video at low resolution, upscale the latent, and then refine it at high resolution. Generate low to upscale latent to refine high. This gives us another way to create high resolution MiniMax H3 video without needing to generate everything at high resolution from the beginning. Thanks for watching, and I'll see you in the next video.
Woke up with a rooster singing, coffee on the stove.